A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was reading a critique of large language models the other day that really stuck with me. It basically argued that no matter how much we scale these things, no matter how many trillions of parameters we throw at them, they are still just fancy autocomplete engines. The term they used, which has become a bit of a lightning rod in the industry, was stochastic parrots. And honestly, when you see a model hallucinate a complex relationship between two people who have never met, or confidently invent a chemical reaction that would actually blow up a lab, it is hard to argue with that critique. It feels like the AI has the gift of gab, but no actual ground to stand on. But today's prompt from Daniel is about something that might finally prove that critique wrong. He's asking us to dive into knowledge graphs as the backbone of AI memory and context. This isn't just a minor update. It feels like we are finally giving the parrot a brain.
I am so glad Daniel brought this up because we are at a massive turning point right now in March of 2026. I am Herman Poppleberry, and I've been spending my late nights lately digging into the research coming out of Microsoft Research and Neo4j. For a long time, the industry was obsessed with vector databases. We thought that if we could just turn everything into a mathematical coordinate, the AI would understand it. Vectors are great for finding similar things, but they are terrible at understanding how things are actually connected. Knowledge graphs are the antidote to the stochastic parrot problem because they provide a structured, logical map of the world that the AI can actually follow. We are moving from the era of pattern matching to the era of actual reasoning.
It feels like we are moving from a world where the AI just has a vibe about the answer to a world where it can actually show its work. It is the difference between a student who guessed the right answer on a multiple choice test and one who can derive the formula on the chalkboard. But before we get too deep into the weeds of the technical implementation, let's establish the basics for everyone listening. When we talk about a knowledge graph, we are not just talking about a standard table in a database or a spreadsheet. We are talking about nodes and edges, right?
That is the core of it. Think of a node as an entity. It could be an object, a person, a place, a protein, or even an abstract concept like democracy. Then you have the edges, which are the explicit relationships between those nodes. So, Daniel is a node, Jerusalem is a node, and the relationship between them is Libsyn. In a traditional database, you might have that information buried in a row in a table called users, but in a graph, that relationship is a first-class citizen. It is just as important as the data itself. This creates what we call a semantic backbone. When an AI looks at a graph, it is not just seeing a list of words or a cluster of vectors, it is seeing a network of meaning. It understands that if A is connected to B and B is connected to C, there is a logical path it can follow.
And that is a huge shift from how most people think about AI memory right now. Most of the conversation for the last 2 years has been about retrieval augmented generation, or RAG, using vector search. We talked about this back in episode 846, where we used the analogy of shouting into a library and hoping the right book falls off the shelf. Vector search is basically looking for books with similar covers or titles. It is a statistical guess, but what you are saying is that knowledge graphs turn that library into a highly detailed interactive map where every book is cross-referenced by its actual content and logic.
The map analogy is perfect. In a standard vector-based RAG system, the model takes your question, turns it into a mathematical vector, and looks for pieces of text that are mathematically close to it in a high-dimensional space. But mathematical closeness does not equal logical relationship. If you ask a complex question that requires connecting 3 different ideas, vector search often fails because those ideas might be stored in completely different sections of the library. Knowledge graphs enable what we call multi-hop reasoning. You start at node A, follow the edge to node B, and then follow another edge to node C. The AI can traverse the graph to find the answer even if the information was never written down in a single sentence anywhere in the training data. This is how we get past the pattern matching phase.
That sounds incredibly powerful. But if it is so much better, why hasn't everyone been doing this from the start? I remember back in 2024, people were talking about knowledge graphs like they were this ancient, dusty technology from the semantic web era that was too hard to use. My understanding is that building these graphs is a massive pain. You can't just dump a bunch of PDFs into a graph database and call it a day like you can with a vector store. You have to extract the entities, define the relationships, and keep it all updated. It sounds like a data engineering nightmare.
You have hit on the primary hurdle, the cost cliff. Up until very recently, knowledge graphs were considered an academic curiosity or a luxury for massive enterprises with unlimited budgets. In 2024, indexing a large corpus of data for something like Microsoft's original Graph RAG could cost anywhere from $20 to $500 depending on the size of the data. Compare that to a couple of dollars for a standard vector index. It was a cost cliff that most developers just couldn't justify for a prototype. But that changed in June of 2025 with the release of Lazy Graph RAG.
Lazy Graph. RAG. I love the name, but I assume it doesn't mean the developers were just sitting around. What is the actual mechanism there that fixed the cost problem? How do you make a graph lazy without making it useless?
It is a brilliant bit of engineering that really speaks to the maturity of the field in 2026. Traditional Graph RAG tries to index every possible relationship up front. It reads every document, extracts every entity, and maps every connection before you even ask a question. It is exhaustive, but it is also incredibly expensive because you are paying for the LLM to process thousands of relationships you might never actually query. Lazy Graph RAG basically says, let's not build the whole map until we know where the user wants to go. It uses the LLM to extract only the most relevant entities and relationships on the fly or in small incremental batches based on the user's intent. It reduced indexing costs to 0.1% of the original levels. We are talking about going from a $500 bill to a 50-cent bill. That single development took knowledge graphs from something that only a company like Merck or Bayer could afford to something a startup can run on a shoestring budget.
That explains why my feed has been blowing up with graph talk lately. It is finally practical for the rest of us. And speaking of Merck and Bayer, those are some heavy hitters. I saw that Merck built something called Synaptics on top of Neo4j. Why is a pharmaceutical giant so invested in this specific architecture? What can a graph do for a drug company that a standard search engine can't?
Think about the complexity of drug discovery. You have thousands of proteins, tens of thousands of chemical compounds, and millions of research papers spanning decades. If you are trying to find a new use for an existing drug, which we call drug repurposing, you need to know more than just what the drug is similar to. You need to know this drug inhibits this specific protein, which is overexpressed in this specific disease, but only in patients with this specific genetic marker. That is a multi-hop query. A vector search might find papers about the drug and papers about the disease, but it won't necessarily connect the dots of the biological mechanism. Merck's Synaptics platform connects all those fragmented pieces of knowledge across preclinical research and clinical trials. It allows their researchers to ask questions that bridge 20 years of research in seconds. They are literally finding new life-saving uses for old drugs by following the edges in their graph.
It is basically a search engine for biological logic. And Bayer is doing something similar with what they call patient maps, right? Linking molecular data to clinical outcomes. It makes you realize that the real value of AI in 2026 isn't just generating text. It is navigating the complexity that humans can no longer keep in their heads. We have reached a point where there is too much data for any one scientist to synthesize, so we need the graph to hold the structure while the LLM does the talking.
And that brings us to the business side of this, which is where things get really interesting. McKinsey put out a report in 2025 that was pretty sobering. They found that 71% of organizations are using generative AI regularly, but only 17% are seeing a significant impact on their bottom line. There is this massive gap between a cool demo that writes a poem and a production system that actually makes money or saves time. The reason for that gap is often the truth conflict, which we explored in episode 1100. Models ignore the facts you give them because they trust their internal training data more. Knowledge graphs solve this because they provide a verifiable, structured context that the model can't easily ignore. It bridges that demo to production gap by providing actual accuracy. When you can point to a specific node and edge, the LLM has a much harder time hallucinating.
I want to shift gears to something that feels a bit more day to day for a lot of our listeners, which is code. Daniel mentioned mapping out code repositories. I have seen tools like GitHub Copilot getting much better at understanding the context of a whole project, not just the file you are working on. Are they using graphs for that? Because navigating a million lines of code feels like the ultimate multi-hop problem.
They are, and it is one of the most practical applications of this tech. If you think about a code base, it is already a graph by nature. Functions are nodes. A function calling another function is an edge. A class inheriting from another class is an edge. A variable being passed into a module is an edge. When you use a tool that has workspace awareness, it is often building an abstract syntax tree and then projecting that into a graph. If you ask an AI agent to refactor a piece of code, it needs to know every single place that function is called across the entire repository. A vector search might find the function definition because the names are similar, but it might miss a call in a completely unrelated folder that uses a different naming convention. A graph never misses it because the connection is explicit in the code structure.
That explains why agentic workflows are finally becoming reliable. If the agent can traverse the graph of your codebase, it has a level of situational awareness that a simple text-based model just doesn't have. It is like the difference between someone who has read a travel brochure about a city and someone who actually has a GPS map of the streets. The brochure gives you the highlights, but the GPS tells you exactly which turn to take to avoid the dead end.
The GPS analogy is great, and what is interesting is how this is changing the role of the developer. We are moving away from just writing code to being architects of these knowledge structures. If your data is a mess, your knowledge graph will be a mess. We are seeing a huge trend where companies are realizing they have to clean up their data maturity if they want to benefit from graph RAG. It is becoming a competitive moat. If you have a proprietary, high-quality knowledge graph of your industry, whether it is legal, medical, or technical, you have an AI that can outthink any generic model trained on the public internet. You are essentially building a private brain for your company.
It is the ultimate defense against the commoditization of LLMs. If everyone has access to the same powerful models from OpenAI or Google, the winner is the one with the best memory layer. But let's talk about the tension here. You mentioned earlier that the emerging consensus is a hybrid approach. Why not just go full graph for everything? Why do we still need vectors at all if graphs are so much more accurate?
Because vectors are still king when it comes to ambiguity and fuzzy matching. Humans are not always precise. We ask questions using synonyms, slang, or vague descriptions. Graphs are very rigid. If you ask a graph about a car, but the node is labeled vehicle, a strictly logic-based graph might struggle to make that connection unless you have explicitly defined that relationship. Vectors handle that linguistic nuance effortlessly. The modern AI stack uses vector search to get into the right neighborhood, to find the general area of the library, and then uses the knowledge graph to navigate the specific houses and streets. It is the best of both worlds. You get the intuition of the vector and the logic of the graph.
So it is not an either-or situation. It is a layering of different types of memory. You have the short-term memory of the context window, which is getting huge, but is still volatile and prone to losing the thread. You have the long-term fuzzy memory of the vector store, and now you have this structured, logical memory of the knowledge graph. It feels like we are finally building a digital brain that mirrors how we actually think. We have intuition, which is like the vector search, and we have logic, which is the graph.
I love that framing. It really is a System 1 and System 2 thinking model for AI. The Microsoft research team has been very vocal about this with their Graph RAG project. They are not just looking at it as a better way to do search, they are looking at it as a way to give AI a form of global reasoning. In a standard RAG system, the AI only sees the specific chunks of text it retrieved. It is looking at the world through a straw. In Graph RAG, the model can see the entire structure of the data. It can summarize themes across thousands of documents because it can see the clusters of nodes and how they relate to the whole. It can tell you what the most important concepts are in a dataset without you even asking about them.
That is a massive point. I have tried to get LLMs to summarize large datasets before, and they usually get overwhelmed or start focusing on the most recent things they read. If the graph can pre-summarize those clusters, the AI is starting from a much higher vantage point. It is not looking at the trees, it is looking at the forest. This is why the accuracy numbers are so different. On complex multi-hop queries, Graph RAG is hitting 80% accuracy compared to maybe 50% for traditional vector RAG. That is a 3.4 times improvement on some enterprise benchmarks. In a business context, 50% accuracy is a toy. It is a coin flip. 80% is a tool you can actually start to rely on for decision making.
And that is why Gartner has categorized knowledge graphs as a critical enabler in 2026. They are no longer a nice to have. If you want to move past the demo phase, you need this layer. We should probably mention the tools for people who want to actually build this. You mentioned Neo4j, which seems to be the dominant player in the graph database space. They have been doing these Graph Talk events for the pharma and life sciences industries, and it seems like they are the go-to for these massive projects like what Merck and Bayer are doing. But what about the average developer who just wants to improve their RAG system? Neo4j is definitely the leader, and they have done a great job making their tools more AI-friendly with their recent updates. But if you are just starting out, I would highly recommend checking out the Microsoft Graph RAG repository on GitHub. It is open source, and it is a great place to see the actual implementation logic. There is also Flurry, which has been doing some really interesting work on making data graph ready for 2026. They focus on the data integrity side, making sure the facts you are putting into the graph are actually true and verifiable. The barrier to entry is dropping every single month. You don't need a PhD in graph theory anymore to get started.
What about the hardware side? This show is powered by the GPU credits from Modal, and I imagine that extracting these entities and building the graph is still a fairly compute-intensive process, even with the lazy indexing methods. You're still asking an LLM to do a lot of heavy lifting to identify those nodes and edges.
It is. You are essentially running a lot of small inference jobs to identify the nodes and edges. This is why serverless GPU platforms like Modal are so important for this workflow. You don't want to keep a massive cluster running 24/7 just to update your graph. You want to spin up the compute, process a new batch of documents, update the edges, and then shut it down. The cost efficiency of the software side, like lazy graph RAG, combined with the efficiency of the hardware side, is what has made this whole thing viable for the mainstream. We are finally seeing the infrastructure catch up to the ambition of the researchers.
It feels like we are finally moving past the hype phase of generative AI, where everyone was just amazed that the dog could talk, and we are moving into the phase where we actually care what the dog is saying. If the dog is giving me medical advice or refactoring my code, it better have a knowledge graph behind it. I don't want a stochastic parrot, I want a digital expert.
I think that is going to be the standard by the end of this year. We will reach a point where if an enterprise-grade AI doesn't have a structured knowledge layer, it will be seen as a toy. It is the only way to get the reliability and the auditability that serious industries require. You can actually point to an edge in a graph and say, the AI said this because of this specific relationship between these two nodes. You can't do that with a vector embedding. A vector is just a string of numbers that no human can interpret. The graph brings transparency to the black box.
That auditability is huge, especially from our perspective. If you are pro-accountability and pro-transparency in tech, knowledge graphs are a massive win. It takes the black box of the LLM and puts a clear, human-readable structure next to it. It is a way to keep the AI honest. If it makes a claim, you can verify it against the graph. It is like having a fact-checker built into the memory of the system.
It also helps with the context boundary problem. One of the biggest issues with long context windows, even as they hit millions of tokens, is that the model can still lose track of how facts relate to each other over 100,000 tokens. It gets lost in the noise. A knowledge graph acts as a permanent anchor. It doesn't matter how long the conversation goes, the core facts and their relationships remain stable and accessible. This is the signal-to-noise solution we talked about in episode 810. It keeps the AI focused on what matters.
So, what is the takeaway for the people listening who are building products or managing teams? Is it time to ditch the vector database and move everything to Neo4j? Is the vector era over?
Not necessarily. The takeaway is to stop treating your data like a flat pile of text. Start thinking about the entities and the relationships. If you are building RAG system today, you should be evaluating whether a hybrid approach is right for you. If your users are asking complex questions that require connecting multiple dots, the multi-hop reasoning we talked about, standard vector search is going to let you down. You need to look into graph, RAG. And with the cost coming down so dramatically thanks to lazy graph. RAG, there is really no excuse not to at least prototype it. The tools are there, the research is solid, and the accuracy gains are too big to ignore.
It is about data maturity. You have to do the hard work of structuring your knowledge if you want the AI to be truly intelligent. There are no shortcuts to actual knowledge. Daniel really hit on a fundamental shift here. It is the move from pattern matching to actual reasoning. It is about moving from an AI that guesses to an AI that knows.
And that is the most exciting part for me. We are seeing the birth of a new kind of software architecture. It is not just code and data anymore, it is code, data, and meaning. The knowledge graph is where that meaning lives. I think we are going to look back at the vector-only era of 2023 and 2024 as the prehistoric age of AI memory. We were just banging rocks together back then. Now we are building maps.
I can see the headlines now. The death of the stochastic parrot. It is a much more hopeful vision of where this tech is going. It is less about replacing human thought and more about organizing human knowledge in a way that an AI can actually help us navigate. It makes the AI a better partner for us.
I am optimistic. We are moving toward AI that knows, and that is a much better partner than an AI that just guesses. Whether you are in drug discovery, software engineering, or legal research, the graph is what is going to make your AI indispensable.
I think that is a perfect place to wrap this one up. We have covered a lot of ground, from the technical mechanics of nodes and edges to the massive cost reductions of lazy graph RAG and the real-world impact in pharma and code intelligence. It is clear that knowledge graphs are the missing piece of the puzzle.
It has been a blast. I could talk about graph theory and its implications for AI all day, but I think we have given people a solid foundation to start their own exploration. The field is moving so fast right now that by the time people listen to this, there might be even more breakthroughs.
If you want to dive deeper into the technical side, definitely check out the Microsoft Graph RAG repository on GitHub. And if you're interested in the enterprise side, keep an eye on what Neo4j is doing in the life sciences space. There is so much happening right now, especially with the Bio-IT World Expo coming up in May.
Before we go, a big thanks to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes and making sure we don't get lost in our own graph.
And a huge thank you to Modal for providing the GPU credits that power the generation of this show. We literally couldn't do this without that compute. It is what allows us to process the data and bring these insights to you every week.
This has been My Weird Prompts.
If you are enjoying these deep dives, please consider leaving us a review on your favorite podcast app. It really does help other curious people find the show and join the conversation.
Or you can find us on Spotify if you want to make sure you never miss an episode. We have a lot more coming your way.
We will be back soon with another prompt from Daniel. Until then, keep digging into those graphs and looking for the connections.
Goodbye.
See you next time.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth.